Okay, so in these next couple of videos I want to show you some basic software engineering principles. We're going to cover operator overloading, and we're going to do a lot of static stuff. So if you aren't comfortable with static or operator overloading, this is a great place to pick on up. Okay, so first of all, this is just a regular console application. I'm going to add a new class, and we're going to create a class for distance. So if you're working on a project and you need to keep track of distance, and maybe your team doesn't have excellent communication, or maybe you just need to use it, in multiple parts of the globe, it would be useful to have, a class to represent distance. So instead of having to keep track of int x miles, int y equals 10, and this being in meters, you can see how a system like this could get very confusing very quickly and is, really, really brittle. Because if somebody uses the wrong thing in the wrong place, it could be, catastrophic. Now you could make this a little better by, x miles, but we want to try and protect ourselves from accidental mistakes like that. So we're going to create an entirely separate distance class. Okay, so let's start things out. First, let's keep this nice and lean. First off, we'll make this public so it can be accessible from program. Okay, so the idea behind this distance class is we want to have a single value inside the class that represents distance, and we want all other, derivative distance units to be calculated from our base unit. So that's kind of a mouthful that may come off as confusing. It'll be much more obvious when I show you. Now what I'm going to try and do for this one is I'm going to go step by step and I'm going to do something, and then I'm going to backtrack and tell you, why maybe not to do that, and, well, why maybe to prefer another way. Okay, so number one, let's just pick a value. So we'll go with meters arbitrarily, and we're just going to focus on meters and miles for now. So let's say we have a private variable, a double perhaps, and we'll have meters. And this is how we're going to track the units internally, but of course we don't want the callers to know that. We just want to know that we have, a distance class that can feed us meters or miles or whatever else we want it to. Okay, so already I have a problem with this. Now, this might not be an especially huge deal. I mean, particularly if you're using distance for, like, physics calculations or something like that. But when it comes to man-made values, rather than using double, it's usually preferable to use decimal. Now this is like a double, but it's a C# unique type, 128 bits, I think. But it keeps track of decimal numbers really, really precisely. So this is useful, if you have 0.5 plus 0.5 or whatever, it'll get you 1.0 every single time. And any of you who have worked with doubles and floats before know that they can be finicky, and you have to, check for round off, and doing a direct double equals comparison doesn't work very well because, they aren't stored perfectly. Decimals are, really, so you can trust them to do things accurately. And the reason that I like decimals here is because, well, for one, it's an academic exercise, so it's nice to expose you to this type. This is the kind of thing you always want to use if you're doing money, by the way, or anything else man-made and important. But for this case, I like it because, the conversion between miles and meters is, a man-made one. So we'll just use this for now. Decimal is actually pretty slow, so in reality it might be better to prefer a double here, but we'll leave it in here as an academic exercise for the fun of it. Okay, so moving on. So let's make a constructor. We'll do distance, public distance, and of course we're going to want to initialize distance with a value. Let's just start with a default constructor though. Okay, so we'll set meters equal to 0. That seems like a reasonable thing for the default constructor to do. And then let's create another constructor. And this one we're going to feed a decimal in. And here's immediately a problem, is if somebody is constructing a decimal, we could tell them to put meters in here, but what if they don't put meters in here? Excuse me. Well, for now, we're just going to ignore this issue. We're going to sidestep it. We're going to pretend that our client is always going to put this in. The reason we don't want to leave this is the exact same problem we had before, remember. We're simply telling the user to do it. We're not forcing them to. You know, we're not compiler checking to make sure that they're using the correct units. So for now, we'll just assume that this is okay. Okay, so we'll say this dot meters equals meters. Darn it. I'm trying to keep this formatting compact so we can see as much on the screen at one time as possible. There we go. So, notice that you can use this dot meters, and this will refer to this meters. You can see how Visual Studio highlights it. And this meters will refer to, this input meters. And this is a nice, little syntactic sugar that C# allows you to do, and I recommend you do it whenever, whenever it makes sense, like right now. So, okay, we'll do a constructor like this. Now, as a review, we're going to do constructor chaining here because, look, we're setting meters here and we're setting meters here. And what if we wanted to change the logic or, maybe add some checking to make sure we didn't have a negative distance for whatever reason? So, rather than doing this, we're going to do constructor chaining. So, remember the syntax is colon, and then we're going to say this, because we're calling this constructor, not a base constructor. We don't need that anymore. Instead of doing meters equals 0, we're going to call our other constructor and feed in a 0 here. Now remember, whenever you do constructor chaining like this, what this basically does is it copies and pastes this body in here before any of your code here is run. Okay, so we have that. Now, we don't want the user to really know that this is stored as meters. So we want to implement a couple of functions. We're going to have a public decimal, and we'll say as meters. And then we'll have a public decimal as miles. So see, whenever they have a distance class, they can't directly access our meters like this. We don't want them to know that our meters are stored like this. Instead, they'll either call as meters to get the distance in meters, or as miles to get the distance in miles. Now, as meters is quite simple. All we're going to do here is return our meters. Nice and easy. As miles is a little different because there's a conversion involved here. So what we're going to do is we're going to return our meters, and we're going to multiply them by a constant. And I looked this up and copied it over ahead of time. So we're going to slap this on here. And notice that at the end of this, there's a little m, big M, you can do either. All this means is use a decimal literal. If we did this, this would default to a double. Whenever you have, a decimal point number like this without a suffix, that's a double by default in C#. An F will make it a float, and an M will make it a decimal. So that's why there's an M here. This doesn't have anything to do with meters or miles. Don't be confused by all the M's. Okay, so this seems pretty reasonable. You can get your distance as meters, you can get your distance as miles, and if we really wanted to, we could add more stuff here. We could add, for example, inches and kilometers and feet. But we're not going to concern ourselves with that for now. So this is where we're going to stop for now, because this is getting to a good breaking point, and I'm almost going over the YouTube limit. But next time we're going to go over the operator overloading, and we're going to work a little bit more with static methods.